So, in late 2022, there were a couple of guys from this startup called Make Sunsets.
Oh yeah, the weather balloon guys.
Exactly. They drove out into the desert in Baja California, down in Mexico, and they had this weather balloon, like just the kind you can buy online for a science project or whatever.
Right, just totally off the shelf.
Yeah, and they hooked it up to a canister and pumped it full of sulfur dioxide gas, tied it off, and just let it go. They literally just stood there and watched it float up into the sky until it disappeared.
It is wild to think about.
I mean, there was no United Nations permission, no environmental impact review, no consultation with the Mexican government at all. They just decided on a random Tuesday that they were going to start hacking the Earth's climate.
I mean, it really sounds like the cold open to a dystopian sci-fi movie.
Yeah.
But it was entirely real. And I think it perfectly encapsulates the sort of Wild West reality of exactly where we are right now.
Yeah. It's a terrifying reality. So welcome to the deep dive. We are thrilled you're joining us today because your mission, well, I guess our mission really, is to unpack this towering stack of sources about a topic that is just rapidly moving from the fringes of science fiction directly into our geopolitical reality.
And the sources are intense. We are looking at United Nations diplomatic reports and game theory analyses from the London School of Economics.
Right, and massive climate modeling data, and also these newly released ethical frameworks from the American Geophysical Union. And it is all centered on one incredibly high-stakes concept, which is climate geoengineering.
It is arguably the single most controversial scientific and geopolitical topic of our time. And the reason we are talking about, random weather balloons in Mexico is because the abstract debate is totally over. We have entered the era of rogue actors and entirely unwritten rules.
Yeah, humanity is seriously considering intentionally manipulating the Earth's climate system. And just to be clear for everyone listening, we aren't talking about the accidental warming we've caused over the last century and a half by burning fossil fuels.
No, this is deliberate planetary scale engineering.
Exactly. And the driving force behind this, the terrifying math of it all, honestly, is that our global emission reductions are just falling drastically short. We aren't cutting greenhouse gases fast enough, so scientists and increasingly politicians are looking for an emergency brake.
And pulling that emergency brake brings up some profound dilemmas. So today, we are not just going to tell you what these technologies are. We're really going to look under the hood at exactly how they physically work and why they are so incredibly dangerous.
And how they threaten to completely upend global geopolitics and economics and really our fundamental relationship with nature. We are basically flying a planetary aircraft right now, and the terrifying truth is that we are trying to build the navigation system while the plane is already in the air.
That's a perfect way to put it.
Okay, let's unpack this, because before we can even begin to debate the ethics or the geopolitics, we really have to understand the tools in the toolbox. We need to know the actual physics of what we are proposing to do to the Earth.
Right, we have to define the tech.
Yeah, and based on our stack of sources, climate intervention geoengineering basically falls into two totally distinct buckets. You have carbon dioxide removal, which goes by the acronym CDR, or sometimes negative emissions technologies, NETs.
And then in a completely different category, you have solar radiation modification, or SRM.
Right, so let's dig into the actual mechanics of these, starting with the first bucket.
Okay, let's start with carbon dioxide removal. The whole philosophy here is remediation. You are basically trying to clean up the mess. The goal is to pull the legacy carbon, billions of tons of CO2 we've already emitted, out of the ambient atmosphere and put it somewhere safe and permanent.
But doing that is incredibly difficult, right? Because CO2 in the atmosphere isn't like a thick cloud of smog you can just vacuum up. It's really diffuse.
Very diffuse, yeah. It's well mixed globally.
Right. It's about 420 parts per million right now, which means for every million molecules of air, only 420 of them are carbon dioxide. So trying to grab them is basically like trying to pick a specific grain of sand out of a sandbox while blindfolded.
That's a great analogy, which is exactly why the technologies proposed to do this have to operate on a staggering, almost incomprehensible scale. The sources detail a few different approaches to this, so let's look at one that leverages the natural world first.
Okay.
It's called ocean iron fertilization, or OIF.
Right. This is a fascinating mechanism. But how does dumping iron into the ocean actually pull carbon out of the sky?
Well, it relies on something called the biological carbon pump. So the surface of the ocean is filled with phytoplankton, which are these microscopic marine algae.
Yeah.
And like plants on land, they photosynthesize. They take in sunlight and CO2 to grow.
Right. Simple biology.
Exactly. But in vast areas of the ocean, particularly down in the Southern Ocean, these phytoplankton are essentially starving. They're starving for a very specific micronutrient, which is iron. Iron is the limiting factor for their growth.
So if you sail a massive freighter out there and just dump a slurry of iron dust into the water, you essentially trigger an artificial explosive bloom of phytoplankton.
You do. They go into an absolute feeding frenzy. They multiply by the trillions, and as they do, they suck massive amounts of CO2 out of the surface water.
And because the ocean absorbs CO2 from the air to maintain an equilibrium,
Right.
the ocean pulls more carbon down from the atmosphere to replace what the algae just ate.
Exactly. But here is the critical part of the mechanism, because pulling the carbon into the water isn't enough. For it to actually be considered removed, it has to stay out of the atmosphere for centuries.
Has to be locked away.
Yeah. So the theory behind OIF is that when these trillions of phytoplankton eventually die, their carbon-rich bodies will clump together and sink into the deep ocean abyss. It's a process marine biologists actually call marine snow.
Marine snow, wow.
And once it hits the ocean floor, that carbon is locked away in the sediment for thousands of years.
Okay, so that's the biological approach, but then the sources also detail these heavy land-based industrial approaches, right? Like direct air capture or DAS, which is getting a ton of venture capital funding right now.
Yes, Silicon Valley loves DAC.
And the physical engineering of this is just wild. We aren't planting trees here. We are building massive factory-sized machines that literally breathe the air.
Yeah, they essentially look like giant banks of industrial fan blades. And the mechanics are pure chemical engineering. These giant fans pull ambient air into the facility and force it over a contactor.
And what's a contactor exactly?
It's basically a surface coated with a chemical, often a liquid solvent, like an amine solution or a solid sorbent filter.
And what do these amines actually do?
Well, amines have a very specific chemical affinity for carbon dioxide. So as the air washes over the liquid, the amine molecules bind specifically to the CO2 molecules trapping them. Meanwhile, they let all the nitrogen and oxygen just pass right through and exhaust out the back.
So it's basically a chemical sponge.
Exactly, but that's only step one, because now you just have a liquid solvent that is totally saturated with carbon.
Right, you have to get the carbon out of the sponge, so to speak, so you can reuse the sponge.
Precisely. And this is where the massive energy penalty comes in. Because to break that chemical bond and release the pure CO2 gas from the solvent, you have to heat it. And you have to heat it to incredibly high temperatures.
Like how high are we talking?
Some processes require heating the materials to nearly 900 degrees Celsius.
Wow, that's intense.
It requires a massive amount of energy. But once you heat it, the pure CO2 gas is released. Then you capture it, compress it into a highly pressurized liquid state, and pipe it deep underground into porous rock formations where it eventually mineralizes and basically turns to stone.
Man, it's a phenomenally complex and energy-intensive process. And then there is the third major technology in this first bucket. And this is one we are really going to spend a lot of time on today because the climate models absolutely rely on it.
Yes, bioenergy with carbon capture and storage. BECCS.
BECCS. It's a multi-stage behemoth of a process. It basically attempts to generate electricity and remove carbon at the exact same time.
Right, so step one, you grow massive amounts of biomass. Think of vast continent-spanning plantations of fast-growing crops like switchgrass or coppiced willow.
Just huge fields of it.
Right, and as these plants grow, they perform photosynthesis naturally, pulling CO2 out of the air.
Okay, and then step two, you harvest all that biomass, you dry it out, and you transport it to a specialized power plant. You essentially burn the biomass to boil water, create steam, spin a turbine, and generate electricity for the grid.
But step three is the magic trick. Because instead of letting the exhaust from that burning biomass just go up the smokestack and back into the atmosphere, you install a chemical scrubber right in the flue.
Oh, so you catch it right as it burns.
Exactly. You capture all that concentrated CO2 right at the source, you compress it, and you pump it deep underground, just like with direct air capture.
And because the plants pulled the carbon from the air originally and you buried the emissions underground, the entire process is theoretically carbon negative.
That's the theory. You generated power, and the atmosphere has less carbon in it than when you started.
Okay, so those are the main tools in bucket one. Carbon dioxide removal. It's slow, it's incredibly expensive, highly industrial, and focused on actually removing the root cause of the warming.
Yes, cleaning up the mess.
But bucket two. Bucket two is solar radiation modification, SRM. And when you read the scientific literature on this, I mean, this is where you can genuinely feel the anxiety radiating off
Eh,
the pages.
Oh, absolutely. Because SRM doesn't remove a single ounce of carbon from the atmosphere. It does absolutely nothing to address ocean acidification or the actual chemical buildup of greenhouse gases.
It just masks the warming effect.
Right. It is a massive optical illusion.
Hmm.
The entire goal is just to reflect a tiny fraction of incoming sunlight back into space before it can hit the Earth and turn into heat.
And the sources outline two primary methods for achieving this reflection. The first one is marine cloud brightening, which isn't about making clouds from scratch, right? It's about altering the microscopic physics of existing clouds over the ocean.
Yeah, to understand marine cloud brightening, we really have to look at the physics of how clouds form in the first place.
Yeah.
Clouds are made of water vapor that condenses into liquid droplets. But water vapor can't just condense in empty space. It needs a microscopic surface to grab onto.
Like a seed.
Exactly. Scientists call these cloud condensation nuclei. In nature, this is usually a tiny piece of dust or pollen or maybe sea salt kicked up by the ocean waves.
So the proposal here is to launch fleets of these unmanned wind-powered ships across the oceans. And these ships would basically just constantly pump seawater through specialized nozzles, right? Spraying a fine mist of microscopic sea salt crystals high into the marine boundary layer of the atmosphere.
And this leverages a phenomenon known in physics as the Toomey effect.
The Toomey effect. Okay.
Yeah, so if you introduce billions extra microscopic salt crystals into a cloud, the available water vapor condenses around these new seeds. So instead of the cloud being made up of a smaller number of really large water droplets, it becomes made up of a massive number of very tiny water droplets.
And why does the size of the droplet actually matter for the climate?
It's all about surface area. A cloud made of billions of tiny droplets has a much larger total surface area than a cloud made of fewer large droplets.
Ah, I see.
And more surface area means the cloud is vastly more reflective. It physically looks wider from space.
Yeah.
It acts like a giant mirror over the ocean, bouncing incoming shortwave solar radiation right back out into the cosmos, and that cools the ocean waters below it.
It's brilliant physics, honestly. But marine cloud brightening is highly localized, right? It really only cools the area directly under the clouds.
Right.
The heavyweight champion of SRM, though, the technology that has everyone from the UN to the London School of Economics sweating, is sulfate aerosol geoengineering, or SAG, which is often called stratospheric aerosol injection.
This is the planetary thermostat. The concept here is to fly a fleet of specialized high-altitude aircraft into the upper atmosphere and continuously spray reflective particles, typically sulfur dioxide or hydrogen sulfide.
But the key here, the absolute crucial mechanism that makes this actually work, is where they spray it. You can't just fly a standard commercial 747 and spray this stuff.
No, you absolutely cannot. Commercial jets fly in the troposphere.
Mm-hmm.
The troposphere is the lowest layer of the Earth's atmosphere. It's where all our weather happens. It's highly turbulent, it's full of moisture, and most importantly, it rains.
Right.
So if you release sulfur into the troposphere, it will just mix with water and rain out as acid rain within a matter of days or maybe weeks. It wouldn't stay up there nearly long enough to reflect any meaningful amount of sunlight.
So you have to go much higher. You have to penetrate the tropopause and get up into the stratosphere, roughly 12 to 15 miles above the Earth's surface.
Exactly. The stratosphere is fundamentally different. It is incredibly stable. It is completely dry. There are no clouds, and there is no rain to wash particles away.
Wow.
So if you inject microscopic sulfur particles into the stratosphere, high-altitude winds will eventually spread them across the entire globe, basically wrapping the Earth in a thin, invisible, reflective veil.
And because there's no rain to wash them out, those particles will just stay up there for 1 to 2 years, constantly reflecting sunlight.
Yes.
And the crazy thing is we know this works, not just from computer models, but from catastrophic natural history. The sources point to the eruption of Mount Pinatubo in the Philippines back in 1991.
Yeah, Pinatubo is the ultimate case study for this. When it erupted, it was so powerful that it blasted an estimated 15 to 20 million tons of sulfur dioxide straight through the troposphere and directly into the stratosphere.
So nature basically did the injection for us.
And the results were immediate and global. That sulfur aerosol cloud wrapped around the planet and acted exactly like a mirror. In the year following the eruption, the average global temperature dropped by roughly ½ degree Celsius.
Which is huge.
Yeah, ½ degree might not sound like much to you and me, but in planetary climate terms, it is a massive sudden shock to the system. The entire Earth demonstrably cooled. So stratospheric aerosol injection simply proposes replicating Mount Pinatubo every single year, indefinitely using airplanes instead of volcanoes.
Okay, so we have the mechanics down. We
Yep.
have the giant chemical vacuums. The Iron Ocean dumps the salt-spraying ghost ships and the sulfur-spewing jets.
The whole toolkit.
Yeah.
Yeah.
But the stack of sources we are looking at today doesn't just treat these as engineering problems. The philosopher Dane Scott, in his analysis, insists that we have to look at how these technologies warp our psychology and our morality.
Yes.
He breaks down the ethical divide regarding geoengineering into two really distinct philosophical frameworks.
This is where the physics meets human nature.
Yeah.
Scott outlines what he calls the deep criticism and the pragmatic criticism. So let's look at the deep criticism first.
Okay.
Scott traces this intellectual lineage back to environmental philosophers like Lynn White and Alan Drinson. And from their perspective, viewing geoengineering simply as a scientific tool is a catastrophic mistake. They argue it is a symptom of a deeply toxic, deeply entrenched worldview, what they call a technocratic and instrumentalist mindset.
Instrumentalism, meaning we view the Earth not as a living and interconnected biological web that we are somehow a part of, but as an instrument.
Exactly.
Like a machine. An engine that we stand outside of, pulling levers and adjusting dials to optimize it for human comfort.
Precisely. The deep criticism argues that this exact hubristic attempt to dominate and engineer nature, this unquestioned belief that human technological power is just a universally benign force that can solve any problem, is the exact psychological disease that caused the climate crisis in the first place.
Because we engineered our way into the Industrial Revolution by burning fossil fuels without understanding the consequences.
Right. And now instead of taking a hard look in the mirror, instead of reforming our morals, restraining our consumption, and fixing our break in relationship with the natural world, we are just reaching for a bigger, more dangerous wrench.
Yeah, we're trying to out-engineer our own engineering mistakes. It's like a treadmill we completely refuse to get off.
But then Scott contrasts this with the pragmatic criticism, which he traces back to the legacy of Rachel Carson, the author of Silent Spring.
Which is interesting because Carson was famous for exposing the unintended horrors of chemical pesticides like DDT. So you would think her intellectual descendants would be entirely against spraying sulfur into the stratosphere.
You really would.
Yeah.
But they aren't, are they? The pragmatists look at the terrifying reality of the climate models. They look at the fact that up to 37% of plant and animal species could face extinction by 2050 due to rapid warming.
Yeah, they see coral reefs literally boiling and wet bulb temperatures in the tropics reaching levels where human sweat no longer evaporates, meaning totally healthy people will just die of heat strokes sitting in the shade.
Right. So a pragmatist looks at technological fixes with intense, historically justified skepticism. They know the side effects will likely be severe, but they absolutely refuse to reject these interventions out of hand on purely ideological or moral grounds.
They're looking at the existential threat of near-term warming and saying, hey, we might actually need this to survive.
Exactly. They view geoengineering not as some triumph of human ingenuity, but as a tragic, necessary lesser of two evils to essentially buy humanity time to decarbonize.
Let me throw an analogy at you because I've been turning this over in my head as I read the sources. When I look at the difference between emission cuts and geoengineering, I keep thinking about medical trauma.
Go.
Is geoengineering specifically blocking the sun? Is it like taking a really powerful, highly experimental, unapproved painkiller instead of doing the brutal physical therapy to cure the underlying disease? Like, you know this experimental painkiller might wreck your liver, you know it might cause internal bleeding, but you take it anyway because it masks the agony of a broken bone. You are essentially choosing comfort over a cure.
That aligns perfectly with the deep criticism. You're masking the symptom, you're avoiding the hard work, and you're introducing completely new toxic side effects to your system.
But, and here's the flip side, what if we apply the pragmatist view to that analogy? What if it's not a broken leg? What if we are at the point where the patient has a systemic blood infection and the fever is spiking so high so fast that the fever itself is going to cause lethal brain damage in the next hour? In that scenario, you absolutely need that experimental liver-damaging drug just to crash the fever so the patient survives the night. You aren't curing the infection, but you are buying time so the antibiotics can actually start working tomorrow.
That is the exact agonizing tension right there. Are we treating a chronic condition while actively avoiding diet and exercise, or are we in the emergency room trying to prevent imminent organ failure? And this analogy brings us directly to the most pervasive, immediate fear in the global climate policy world right now.
The moral hazard.
Yes. If you know you have that incredibly powerful fever-crushing drug sitting right there in the medicine cabinet, what happens to your motivation to actually cure the disease?
Right. Why undergo the grueling process of weaning the entire global economy off fossil fuels? Why restructure our entire agricultural system, rebuild our power grids, and accept the political backlash of higher energy prices today if we believe we can just pop a magic pill and block the sun in 30 years?
In economics and climate policy, this psychological trap is called the moral hazard, though ethicists increasingly prefer the much more accurate term mitigation obstruction.
Radiation obstruction.
It is the paralyzing fear that even researching these technologies, even funding lab experiments or writing academic papers about them, will give politicians, fossil fuel corporations, and the general public a convenient, technologically optimistic excuse to just delay cutting carbon emissions right now.
And this isn't just a philosophical worry either, it's actually built into the math. In the source material from Dominic Lanzi, he points out an incredibly disturbing fact about the integrated assessment models.
The IAM.
Yeah, these are the massive supercomputer simulations the IPCC uses to chart our path to a safe climate. He notes that the very design of these models builds mitigation obstruction directly into the code.
Because it's an optimization algorithm problem. These models are designed to find the absolute most economically efficient pathway to keep warming under 1.5 or 2 degrees.
Right.
So if you program the model to allow for massive deployment of negative emissions technologies like BECCS late in the 21st century, the model looks at the cost curves and basically says, oh, it's vastly cheaper to just suck the carbon out of the air in 2080 than it is to aggressively shut down coal plants and retool the global steel industry in 2030.
So the supercomputer is literally recommending that we delay near-term mitigation. It tells policymakers to kick the can down the road because a magical future technology will clean it up cheaper later. The model itself creates the moral hazard.
But here is where we have to pause and really look at historical data, because the narrative of the moral hazard, the idea that even talking about geoengineering will automatically destroy our will to cut emissions, it gets deeply complicated when you look at how humans actually behave.
Right.
One of our key sources, a sweeping historical analysis by Daniel Bodansky and Andy Parker, argues forcefully that not researching these technologies is actually the much graver danger.
Because ignorance breeds false hope.
Exactly. And they point to a highly specific historical example to prove this: the rise and fall of ocean iron fertilization in the late 1980s and 90s.
I loved this section of the source material. It was such a profound reality check because back in the late 80s, ocean iron fertilization was basically the golden child of quick fix climate ideas. The math looked incredibly promising on paper.
Oh, yeah.
There is that famous, almost arrogant quote from the legendary oceanographer John Martin. He gave a lecture in 1988 and joked to the audience, quote, "Give me half a tanker of iron and I'll give you another ice age."
He was summarizing the sheer theoretical leverage of the biological carbon pump we talked about. A tiny amount of iron could hypothetically lock away gigatons of carbon, and immediately environmental groups just panicked.
They raised the alarm of the moral hazard immediately.
They did. They argued that if Martin's quote became public policy, the fossil fuel industry would use it to argue against any emission regulations. They'd say, don't regulate our smokestacks, we'll just buy a freighter full of rust and dump it in the Antarctic.
Right. Environmentalists basically argued that scientists shouldn't even be allowed to test OIF in the real world because the temptation to rely on it would just be too great.
But the scientific community pushed back, and what actually happened? Scientists went out into the open ocean, and they conducted more than a dozen highly monitored field tests. They dumped the iron, they watched the phytoplankton bloom.
And those real-world tests absolutely shattered the illusion of a silver bullet, didn't they?
Completely. The field research revealed that the ecosystem was vastly more complex than the whiteboard equations. Yes, the phytoplankton bloomed, and yes, they absorbed carbon. But the carbon didn't always sink.
Why not? I mean, the theory was so neat, they die and they become marine snow.
Because the ocean is a complex living food web. When the phytoplankton bloomed, zooplankton, these tiny marine animals, swarmed in and just ate them. And when the zooplankton respired, they released the CO2 right back into the surface water.
So it never even made it to the deep ocean.
Furthermore, the sinking organic matter was often broken down by bacteria in the twilight zone of the ocean, the epipelagic zone releasing the carbon long before it reached the deep ocean floor.
Not only that, but the researchers found terrifying potential side effects. The massive blooms threatened to deplete oxygen levels in the water, creating these deep-sea dead zones. And there was even evidence it could trigger the growth of toxic algae that produced domoic acid, which physically poisons marine mammals.
Exactly. Because they did the rigorous public field research, they proved incontrovertibly that OIF was incredibly inefficient and deeply dangerous. And because the facts were laid bare, the hype just died.
Major policy bodies and climate reports quietly backed away from ocean iron fertilization. It was basically taken off the menu of easy fixes.
So in that specific historical case, conducting the research didn't cause a moral hazard at all. It actually killed the false hope. It prevented humanity from making a blind, catastrophic gamble down the line. It proved the painkiller was basically snake oil.
What's fascinating here is that we see this exact same dynamic play out not just with scientists, but with the psychology of the general public.
Right, the Yale study.
Yeah, Bodansky and Parker cite a really compelling sociological study conducted by Yale University. The researchers took groups of everyday citizens in the United States and the United Kingdom, and they exposed them to detailed, scientifically accurate information about solar geoengineering and massive carbon removal.
Which is the critics' absolute worst nightmare, exposing the public to the techno-fix. The assumption was that the public would hear about stratospheric aerosols and say, great, the nerds have figured it out. I'm going to go buy a massive gas-guzzling SUV because the problem is solved.
Right, that's the assumed mitigation obstruction. But the Yale study found the exact opposite effect. It caused a profound reverse moral hazard.
Okay, I want to try to define this clearly for you. A reverse moral hazard means the introduction of the safety net actually makes you behave more cautiously, not less.
Yes. When these citizens actually learned about the extreme, frankly terrifying measures scientists were seriously considering to physically dim the sun or build continent-sized carbon vacuums, they didn't relax, they panicked.
Yep, got scared.
They became significantly more concerned about the reality of climate change. Reading about geoengineering functioned as a visceral wake-up call for them. It drove home the sheer desperate gravity of the climate crisis. The public reaction was essentially, wait, things are so bad that we are talking about putting sulfur in the stratosphere. We need to cut emissions immediately so we never have to actually do that.
And the sources point out that we have real-world national policy data to back up this psychological study.
Yeah.
Just look at the United Kingdom. Throughout the 2010s, the UK government aggressively funded research into geoengineering. They held massive public parliamentary debates about it. They didn't hide it at all.
And did it destroy their political will to mitigate? No. In the midst of all that geoengineering research, the UK legally committed to one of the most aggressive decarbonization schedules on Earth, pledging to cut their emissions by a massive 78% from 1990 levels by the year 2035.
So the research ran parallel to and perhaps even reinforced the urgency of mitigation.
Okay, I hear you. I see the historical data on ocean iron fertilization. I see the Yale psychological study on everyday citizens, and I see the UK's parliamentary record. But and I have to push back here, hard.
Go for it.
Studies on everyday citizens in a controlled academic environment or the parliamentary debates of a single affluent island nation are one thing. But what about the brutal, entrenched political reality of the global economy?
Great. The big players.
What about the multinational fossil fuel conglomerates? What about the multilateral development banks that are right now today funding billions of dollars of massive multi-decade fossil fuel infrastructure in developing nations? I just don't buy that a CEO with sunk costs and a deep water drilling rig experiences a reverse moral hazard and decides to shut it down.
It's unlikely.
Isn't the political reality incredibly ripe for passing the buck? If you are an elected politician whose immediate survival depends on providing cheap, abundant energy today, aren't you going to grab onto the promise of a future carbon-sucking machine like a drowning man grabbing a life raft, regardless of how sketchy the science is?
Your skepticism is entirely justified, and it cuts to the absolute core of the ethical debate. In fact, Henry Shue, a really prominent ethicist discussed heavily in Dominic Lindsay's paper, argues exactly your point.
Oh, really?
Yeah, he looks at the political economy and says that banking on unproven, unscaled future technology while continuing to emit carbon today is not just foolish. It is a deeply unjust transfer of risk.
A transfer of risk from whom to whom exactly?
From us to our grandchildren. Shue argues that we, the current generation, are reaping all the economic benefits of burning fossil fuels right now. But by assuming that future generations will just figure out how to suck billions of tons of carbon out of the air using massive BCCS plantations or direct air capture facilities, we are shifting the entire physical, economic, and ecological burden directly onto them.
We get the cheap electricity and they get the mandate to build a planetary-scale vacuum cleaner.
Exactly. Yeah. And if the technology fails to scale, if the land isn't there, or the energy penalty is just too high, they're the ones who will suffer the catastrophic warming.
And if the politicians do pass the buck, which Looking at global emission trajectories right now is exactly what is happening, and we end up relying almost entirely on pulling carbon out of the air later in the century. We urgently need to understand what that future physically looks like.
We do.
What does it actually mean to scale carbon dioxide removal to a planetary level?
Yeah,
Because when you look at the math in the sources, the scale is genuinely mind-boggling.
it really is difficult to wrap your head around.
Yeah.
Let's go back to Dominic Lindsay's analysis of the IPCC's integrated assessment models for a second. This is a real wake-up call. Lindsay points out that the public narrative is often we must cut emissions to keep warming under 1.5 degrees C or 2 degrees C.
Right, we hear that constantly.
But what the public doesn't realize is that almost all of the pathways the supercomputers generate to achieve those targets rely intensely on negative emissions technologies. Without massive carbon removal later in the century, the carbon budget is already blown. The math simply doesn't work anymore.
And the primary technology these models rely on, the linchpin of our global climate survival strategy, is BECCS, bioenergy with carbon capture and storage.
The one we talked about earlier.
The process of growing crops, burning them, capturing the flue gas, and burying it. Listen to the scale required by these models. To remove the necessary amount of carbon from the atmosphere to hit the 2-degree target BECCS would require a dedicated global land area of roughly 380 to 700 million hectares by the year 2100.
To help you visualize that number, you were talking about a landmass roughly 1 to 2 times the size of the entire country of India.
Devoted entirely to growing biomass just to be burned and buried?
Yes.
I want you to really picture this. Imagine getting in your car in New York City and driving all the way to Los Angeles, and then driving from Seattle all the way down to Miami. And every single thing you see out the window, every field, every plain, every valley, is nothing but a dense monoculture crop of switchgrass or fast-growing timber engineered solely to be harvested for carbon.
It's wild.
Imagine the sheer terrifying hubris of that. We are talking about capturing 10 to 25 years worth of total global CO2 emissions and forcefully injecting it back into the geological strata of the Earth.
And the most pressing question here is, where does that land actually come from? The Earth is finite. You cannot conjure 2 Indias out of thin air. That land has to be seized from somewhere.
So it either comes from clearing natural ecosystems, which means bulldozing remaining ancient forests and wetlands, risking total global biodiversity collapse and the extinction of millions of species, or it comes from converting existing agricultural land,
Which pits the climate directly against global food security. If you take 700 million hectares of farmland and convert it to growing fuel for BCCS power plants, the global supply of wheat, corn, and soy just plummets. Food prices would skyrocket, leading to mass famine, primarily in the developing world.
To explore how this incredibly risky, high-stakes bet on land use plays out, Lindsay introduces a framework used by climate modelers called the Shared Socioeconomic Pathways, or SSPs.
Right, the SSPs are incredibly complex, detailed narrative and mathematical models. They don't just project carbon parts per million, they project different versions of the future based on human behavior, economics, and geopolitics over the next 80 years. They show us how the massive land requirements for nets interact with different societal choices.
Let's walk through 3 of the most prominent SSP scenarios detailed in the sources because they are terrifyingly plausible visions of our future.
Okay, let's start with SSP5. This is officially known as the fossil fuel development scenario. It is the ultimate manifestation of the moral hazard we just discussed.
Okay.
In this world, society makes a conscious choice to prioritize rapid, hyper-globalized economic growth above all else. We just keep burning fossil fuels aggressively for most of the century to drive the global GDP ever higher.
So near-term mitigation is practically zero. We just keep partying and leave the hangover for the year 2080.
Exactly. And because of that catastrophic delay, the amount of carbon in the atmosphere reaches critical levels. To avoid total climate breakdown and hit the temperature targets late in the century, the models show that future generations in SST5 are forced into an impossible, hellish choice.
Which is?
They either have to deploy negative emissions technologies at scales that are completely physically and economically unfeasible. We're talking far beyond the 2 Indias of land. Or, more likely, they simply fail to deploy them in time.
And if they fail?
If they fail, the planet just bakes. The temperature rise crosses irreversible biophysical tipping points. The most terrifying of these is the melting of the Arctic permafrost. The permafrost holds gigatons of trapped methane, a greenhouse gas roughly 80 times more potent than CO2 in the short term.
Oh, wow.
If the permafrost thaws, that methane is released, causing a massive natural spike in warming that no human technology can ever capture or contain. Lindsay points out that the SSP5 pathway is an intergenerational injustice of the highest order. We literally steal the future to fund the present.
Then there's SSP4. Lindsay calls this the deepening inequality scenario. If SSP5 is a story of reckless growth, SSP4 feels deeply disturbingly dystopian because it mirrors so many current geopolitical trends.
Yes, in SSP4, you have a highly stratified world. A wealthy, high-tech global elite dictates policy from heavily fortified, climate-resilient northern cities, while a massive, poor, low-tech underclass struggles in the global south.
So what happens with mitigation in this one?
In this scenario, mitigation does happen, but it's delayed and heavily reliant on market mechanisms. To fix the climate late in the game, the global elites impose a massive carbon tax to force the rapid deployment of BECCS and direct air capture.
And the models predict this carbon price hits an astonishing $2,000 per ton of CO2 by the year 2100. Let's ground that in reality. What does a $2,000 per ton carbon price physically do to your life?
It fundamentally breaks the economy for the average person. At $2,000 a ton, a gallon of standard gasoline would cost roughly $40 to $50. A commercial plane ticket would cost thousands of dollars. But the most devastating impact is on agriculture.
Because of the land use.
Right, because the carbon price makes growing biomass for BECCS incredibly lucrative. Massive corporations buy up global farmland. The models project this would increase global food prices sevenfold.
A sevenfold increase. A loaf of bread that costs $3 today would suddenly cost $21. And the people who suffer aren't the global elites, it's the poor.
Precisely. And this leads to a horrifying geopolitical dynamic that researchers term energy colonialism. To find the land needed to grow all this BECCS biomass, the wealthy nations of the global north essentially recolonize the global south through corporate land grabs.
Wow.
The ancestral forests and subsistence agricultural lands of Africa, South America, and Southeast Asia are forcibly converted into bioenergy crops to serve the carbon-clearing needs of North America and Europe. The risks and the physical footprint of geoengineering are entirely outsourced to the poorest, most vulnerable people on Earth.
It's an unbelievably bleak picture. But Lindsay does offer one scenario that isn't a complete nightmare, right? SSP1.
Yes, SSP1 is the green growth or sustainable pathway. In this world, we basically experience a global awakening. We do the incredibly hard political and economic work early.
Right. We implement aggressive emission cuts. We transition our energy grids to renewables. We redesign our cities for public transit, and we shift our diets now in the 2020s and 2030s.
And because we do the hard work of mitigation early, we fundamentally alter the math for the end of the century. Because we didn't emit the carbon in the first place, we completely minimize the need for massive, risky, negative emissions technologies later.
We don't need 2 Indias worth of land for BECCS. The reliance on extreme, unproven techno-fixes is just drastically reduced.
In fact, the source points out that under the SSP1 scenario, because we manage our land more efficiently and stop deforestation, we could actually see a 63 million hectare gain in natural forests by 2100.
So the hubris is minimized. We aren't relying on planetary-scale technological miracles. We're relying on sustainable, profound changes in human behavior and economics.
But SSP1 requires immediate, unified global cooperation, which is arguably harder to achieve than engineering the climate.
Which brings us to the terrifying pivot in our deep dive today. Everything we've talked about so far in Bucket 1, carbon dioxide removal, BECCS, direct air capture, these technologies share 3 distinct traits. They are incredibly slow, taking decades to build and scale. They require massive, continent-sized physical footprints, and they are astronomically expensive, costing trillions of dollars.
Yeah, very true.
But Bucket 2, solar radiation modification, spraying sulfur into the stratosphere to block the sun. That is an entirely different beast. The sources make it absolutely clear. SRM is incredibly fast. You could drop the global temperature in a matter of months. It has virtually 0 land footprint. And most dangerously of all, it is shockingly cheap.
And that low price tag completely alters the geopolitics. We're talking about retrofitting a relatively small fleet of high-altitude jets and spraying sulfur. Economists estimate it might cost a few $billions a year to cool the entire planet.
A few $billion? I mean, in global geopolitical terms, that is literal pocket change. The United States military spends a few $billions on rounding errors. A single tech billionaire could finance that out of their personal checking account.
Which brings us to a fascinating, deeply unsettling game theory analysis provided in our sources by researchers Daniel Hyen, Joshua Horton, and Juan Moreno Cruz at the London School of Economics.
Right.
They looked at the economics of SRM and realized it creates a massive geopolitical vulnerability known as the free driver effect.
Let's define the free driver effect for a second, because it's the opposite of the classic free rider problem we usually associate with climate change, right?
Hmm.
Where countries won't cut emissions because they hope someone else will do the hard work and they can just ride their coattails.
Right, exactly. In a free rider scenario, nobody wants to pay the high cost of mitigation.
Right.
But with SRM, the cost of deployment is so infinitesimally low that a single wealthy nation, or even a rogue billionaire like the guys in Baja California, but with actual funding, doesn't need a global consensus to afford it.
They don't need the UN to chip in.
No, they can unilaterally decide to deploy stratospheric aerosols and take control of the planetary thermostat. They take the driver's seat, and the rest of the world is dragged along for the ride, whether they consent or not.
So let's play this out using the LSE game theory models, because this is where the geopolitical nightmare truly begins. Imagine country A. Let's say it's a nation near the equator. They are suffering from horrific, deadly, wet bulb heat waves. Their crops are withering. Their power grid is collapsing. Thousands of citizens are dying of heat stroke every summer.
Okay.
Country A's leadership says we can't wait for the United Nations to debate emission targets for another decade. We're in a survival crisis. We are launching the planes and spraying the sulfur tomorrow to cool the planet.
It's a completely rational self-preservation response for country A.
But then look at country B. Let's say country B is a massive superpower situated much further north. Historically, their climate was freezing and inhospitable. But due to global warming, country B is actually benefiting. Their agricultural yields are booming because the tundra is thawing into arable farmland. Their northern shipping lanes are finally free of sea ice, creating a massive economic boom.
Right.
What happens when country A and country B have fundamentally diametrically opposed preferred global temperatures?
That is the exact scenario the LSE researchers modeled. If country A unilaterally deploys cooling aerosols, country B doesn't just have to sit there and watch their new agricultural empire freeze back over. They have agency. And because climate intervention is so cheap, country B might develop counter-geoengineering.
Here's where it gets really interesting. How do you counter geoengineer? If country A is putting up a mirror, how does country B break it?
You don't break the mirror, you build a heat trap. If country A is spraying highly reflective shortwave scattering sulfur particles into the stratosphere to cool things down, country B could deploy specialized short-lived climate forcers into the atmosphere to intentionally warm it back up.
Wow.
The primary candidate for this is specialized black carbon, essentially highly engineered soot.
So we're talking about intentionally polluting the upper atmosphere with black soot. How does that warm the planet?
It's the albedo effect in reverse. Black carbon is incredibly efficient at absorbing radiation. If you spray it at specific altitudes, it absorbs incoming shortwave solar radiation from the sun, and it also absorbs the long-wave thermal radiation bouncing off the Earth's surface.
It traps the heat.
Exactly. It traps the heat in the atmosphere, warming the planet rapidly to counteract country A's cooling veil.
It's the ultimate terrifying planetary scale version of the classic office thermostat war. You know exactly what I mean. Coworker A in the cubicle is sweating, so they aggressively turn on the air conditioning. Coworker B in the next cubicle over is freezing, so they secretly plug in a high-powered electric space heater under their desk.
Yes.
They are literally fighting each other with opposing climate controls.
Yeah.
Except in this case, instead of blowing a circuit breaker in an office building, the fallout is global ecological devastation.
The LSE paper calls this a literal climate clash. It's an escalating arms race of opposing climate interventions. Country A sees the temperature rising again, so they fly more sorties and spray twice as much cooling sulfur. Country B detects the sulfur, so they launch drones to spray twice as much warming black carbon.
And what happens to the actual physical weather systems while these two superpowers are spraying opposing chemicals into the sky?
It creates total atmospheric chaos. The models show that this kind of uncoordinated, conflicting intervention would waste vast resources, destroy the ozone layer, cause severe acid rain, and completely decouple the Earth's precipitation patterns.
The precipitation patterns.
The most terrifying casualty would likely be the global monsoon cycles.
The monsoons. This is critical. Explain the mechanism here. Why does cooling the northern hemisphere disrupt the rain in the tropics?
Monsoons are driven by massive temperature differentials between the land and the ocean. During the summer, the land heats up faster than the ocean. Hot air over the land rises, creating a low-pressure system that sucks in incredibly moist air from over the ocean. That moist air hits the land, rises, cools, and dumps trillions of gallons of water as rain.
Yeah.
It's the engine that waters the crops for billions of people in India, Southeast Asia and parts of Africa.
So if country A unilaterally sprays cooling sulfur mostly over the northern hemisphere, they artificially alter that massive temperature differential.
Exactly. You artificially cool the landmass, which shifts the thermal equator, the intertropical convergence zone southward. The low-pressure engine just stalls. The rain doesn't arrive.
So a unilateral attempt to cool the planet results in a massive human-engineered drought that starves a billion people in a completely different hemisphere.
Right. The game theory models show that if counter-geoengineering is on the table and there's no cooperative governance, this catastrophic clash and the conventional military wars over water that would inevitably follow is a highly probable outcome.
And the most chilling part of this deep dive is that we cannot just brush this off as academic game theory played out on LSE supercomputers. The geopolitical battles over who gets to set the rules and the total lack of trust in the rogue experiments are already happening right now. We are looking at an absolute dangerous vacuum of global governance.
We truly are. Look at the recent attempts by highly respected institutions to conduct even incredibly small-scale, completely harmless field tests. They are unraveling in real time due to a complete lack of global rules, ethical frameworks, and public consent.
Let me tell the story of the ScopeX project because I think it perfectly illustrates this governance failure. ScopeX was a project run by researchers at Harvard University. This wasn't a rogue startup. This was elite, heavily scrutinized academia.
Yes.
Their plan was incredibly modest. They wanted to go to Kiruna, Sweden, and launch a high-altitude balloon. They weren't even going to release sulfur. They just wanted to release a few kilograms of calcium carbonate, essentially chalk dust, to test their instruments and see how the plume dispersed in the stratosphere. It posed zero physical threat to the environment.
And yet it was entirely shut down before it ever left the ground.
Right. It was canceled because of fierce, highly organized opposition. And the opposition didn't come from climate deniers. It came from environmental groups. And crucially, the indigenous Sami people of Sweden, whose ancestral lands the balloon would fly over.
They fought back hard.
The Sami Council wrote this powerful letter demanding the cancellation. They pointed out that they were never consulted in the design of the experiment. But more profoundly, they fundamentally opposed the entire worldview of the project. They echoed the deep criticism we discussed earlier.
Right.
They argued that the sky is not a machine to be tuned by Harvard scientists. They rejected the premise that we should normalize the technology of blocking the sun.
It was a massive failure of sociological governance. Harvard had the physics figured out perfectly, but they had no framework for securing international intercultural consent.
And ScopeX isn't the only example.
No, we already talked about the rogue startup, Make Sunsets, launching sulfur balloons in Mexico, which caused an international incident and led the Mexican government to outright ban all solar geoengineering experiments within their borders.
And just recently, another major academic effort was grounded. The University of Washington had a marine cloud brightening experiment operating off the deck of a decommissioned aircraft carrier in Alameda, California. They were just spraying highly filtered seawater mist into the air to test the nozzles, but it was halted by the local city council.
Oh, wow.
The community raised health and safety concerns, and they cited a profound lack of transparency regarding the long-term goals of the project. So we have this wildly powerful technology that could alter the fate of the planet, and nobody can even agree on how to run a localized nozzle test, let alone how to deploy a global fleet of planes.
And this governance vacuum is happening against a very dark, deteriorating geopolitical backdrop. Danielle Young's paper in our source stack makes a vital observation. She points out that the sudden need for a massive, foolproof global governance structure for geoengineering is occurring at the exact historical moment that the liberal international order, the system of treaties and UN bodies established after World War II, is visibly unraveling.
She points specifically to the collapse of the nuclear arms control regime, doesn't she?
Yes. For decades, the global community managed the apocalyptic threat of nuclear weapons through intense cooperative governance, bilateral treaties, mutual restraint, rigorous verification regimes, and international watchdogs.
But today, those treaties are expiring.
They are expiring, being abandoned, or being openly violated. Young argues this is a terrible omen for climate intervention, because nuclear governance is almost universally cited by political scientists as the only viable historical roadmap for how we might manage the apocalyptic world-altering power of stratospheric aerosols. If we can't manage nuclear warheads anymore, how on earth do we cooperatively manage the global thermostat?
We don't. And the diplomatic friction is already palpable. You can see the fault lines forming. Let's look at the actual United Nations Environment Assembly UNLA 6 that took place in Nairobi in February 2024. This is a defining moment.
It really was.
A coalition of nations led by Switzerland introduced a resolution. And the resolution wasn't to deploy geoengineering. It wasn't even to fund it. The resolution was simply to study it, to convene a UN expert group to gather all the scientific literature and figure out what we actually know.
A completely rational request. And it was killed.
It was killed after days of intense, behind-closed-doors diplomatic fighting, and the factions that formed are incredibly revealing about the future of this technology. Paint the picture of that room for us.
On one side of the negotiating table, you had the United States and Saudi Arabia. Their demand was rigid. They insisted that any UN assessment of geoengineering must be strictly objective and science only. They wanted to look at the physics, the albedo effects, and the temperature drops. They explicitly did not want the UN investigating the ethics, the geopolitics, the governance, or the social justice implications.
Why? Why would you want to intentionally ignore the ethics?
Because if you only look at the science, geoengineering looks like a clean, effective math equation. It strips away historical culpability. It ignores the messy reality of who caused the emissions in the first place and who will suffer the consequences of a disrupted monsoon.
And who was on the other side of the table fighting them?
On the other side were African nations, Pacific Island states, and other climate-vulnerable countries in the global south. They fiercely demanded that any assessment must center on the ethical, social, and political implications.
What were they afraid of?
Their fear, which they articulated very clearly, was a repeat of the SSP4 scenario we discussed. They feared that the wealthy nations of the global north, the exact countries that caused the climate crisis through centuries of unchecked industrialization, would now use the global south as a giant climate laboratory.
Yeah, they feared unilateral deployment that would wreck their agriculture while protecting northern cities.
Exactly. When the U.S. and Saudi Arabia refused to budge on the science-only demand, the African bloc refused to endorse the resolution, and it collapsed entirely.
I want you to really absorb the gravity of that UN fight. If the countries with the advanced industrial and military capacity to literally fly planes into the stratosphere and block the sun are actively refusing to even discuss the ethics of doing so in an open international forum, how can you or anyone in a developing nation trust that this won't just become the ultimate planetary scale form of climate colonialism?
You can't. You absolutely cannot trust it. That profound structural lack of trust is the defining feature of the geoengineering landscape today. The UN is paralyzed. The geopolitical order is fracturing. And that is exactly why independent scientific and environmental institutions are scrambling.
Trying to fill the void.
Right. They're desperately trying to build ethical frameworks from the ground up, hoping to establish normative rules of behavior before the technology outpaces our morality entirely.
Which leads us to the final crucial piece of our deep dive today. Building an ethical framework for the unknown. Because the UN is stalled, other groups are stepping into the void. We have a major report from UNESCO, and crucially, we have a newly released, highly detailed ethical framework from the American Geophysical Union, the AGU.
The AGU is one of the most respected scientific bodies on Earth. They recognize the vacuum, and they spent 2 years consulting globally, not just with atmospheric physicists, but with ethicists, sociologists, indigenous leaders, and policymakers.
They realize that you can't just evaluate geoengineering on a spreadsheet of temperature changes.
Exactly. You have to evaluate how it's researched and deployed. They debated and eventually coalesced around 5 core principles that they argue any climate intervention must follow.
So how do we actually govern this? Let's talk through this framework. The AGU started with the most pressing fear we discussed earlier, which is the moral hazard. Their first principle is responsible research, and they tackle it head-on.
They explicitly state that climate intervention research can never, ever be presented or utilized as an alternative to deep, immediate emission cuts. It must always be framed as a supplement, a temporary painkiller, never the cure.
And their second principle expands the lens globally. Holistic climate justice. This is a direct response to the fears of the Global South at the UN. Before you do anything, you have to prove rigorously that your intervention won't just shift the geographic location of the suffering.
Right. You cannot ethically deploy marine cloud brightening to cool off the coast of California if the models show it will alter atmospheric circulation and cause a devastating drought in sub-Saharan Africa.
Yeah.
You have a moral obligation to protect the most vulnerable populations, not just your own citizens.
Which leads perfectly into their third principle, which I think of as the Sami principle, based on what happened to the Harvard balloon in Sweden. The AGU demand inclusive public participation.
Meaning you cannot conduct research in secret.
Right. It demands free, prior, and informed consent from any populations likely to be affected by the experiments, with a specific highlighted emphasis on consulting indigenous peoples whose lands or skies are involved.
But public participation requires the public to actually know what is happening. Hence the fourth principle, transparency. This is the anti-make sunsets rule. No secret, unannounced startup balloon launches.
The AGU mandates open source data, open access to models, clear public reporting of all activities, and critically a mandate to report negative results.
If an experiment goes terribly wrong or proves a technology is useless, you cannot hide it to protect your venture capital funding. The world must know what doesn't work.
And finally, the fifth principle, informed governance. This calls for independent, robust review bodies. You cannot have the scientists who are designing the aerosols also being the ones who approve their deployment. You can't grade your own homework when the stakes are the chemical composition of the Earth's atmosphere.
These 5 principles, responsible research, climate justice, public participation, transparency, and independent governance, represent a massive vital step forward for human governance. They provide a blueprint for how we should act. But if we connect this to the bigger picture, to the profound philosophical depths of this issue, we have to ask a final unsettling question. Is a human-centric framework, even a just and transparent one, actually enough?
What do you mean by human-centric? The principles talk about protecting vulnerable populations and getting consent.
Yes, but they are focused entirely on humans. Philosopher Toby Svoboda challenges this exact limitation in his paper on the ethics of stratospheric aerosols. He critiques a very popular concept in environmental philosophy known as the convergence hypothesis.
Okay, I want to make sure I understand this. The convergence hypothesis, which I think was originally championed by Brian Norton, basically argues that even if two people have totally different opposing moral philosophies, they will eventually converge on the exact same environmental policy.
That's the gist of it.
So, for example, person A is strictly anthropocentric. They only care about human welfare, human economics, and human survival. Person B is biocentric. They believe that all living things from wolves to forests to plankton have inherent moral rights to exist completely independent of their usefulness to humans.
Right, totally opposite views.
The convergence hypothesis says that despite this massive philosophical divide, they will both vote to protect a local forest. Because person A wants the forest to filter the local human drinking water, and person B wants to protect the habitat of the deer. They arrive at the exact same policy destination just from different starting points.
Exactly. It's a comforting theory because it means we don't have to resolve our deepest philosophical differences to pass good environmental laws.
Yeah.
But Svoboda rigorously argues that when it comes to self-heat aerosol geoengineering SAG, the convergence hypothesis completely shatters. It falls apart.
Why? Why doesn't it hold up when we scale it to the stratosphere?
Because the sheer scale and the biological side effects of dimming the sun disrupt the entire biosphere, not just human infrastructure. Intervening in the global climate affects every single living organism on Earth.
Okay, I see.
An anthropocentric policymaker, let's say utilitarian, focused on human survival, might look at the data for SAG and say, yes, spraying sulfur will alter global precipitation. And yes, it will cause some ozone depletion, but the models show it will objectively save human coastal cities from sea level rise and prevent millions of human deaths from extreme heat. The math works. Let's deploy it.
But the biocentric ethicist looks at that exact same data and sees a horror show.
Precisely. A biocentric ethicist or an animal liberationist would look at that same model and say you are artificially dimming the sun. That alters the fundamental rate of global photosynthesis for every plant on Earth. You are shifting temperatures in a way that will completely scramble the delicate, evolved migratory cues for billions of birds and marine mammals.
Yeah.
The disruption to global habitats, the potential for acid rain to sterilize lakes, is a massive, unjustifiable violation of the inherent rights of trillions of non-human animals. We cannot possibly do it.
So they don't converge at all. They violently diverge. The human-centric ethicist deploys the planes, and the biocentric ethicist grounds them.
Yes, and Svoboda's point is that the ethical frameworks we build right now today must be as expansive as the intervention itself. We aren't just adjusting the thermostat in a human office building, we are violently adjusting the atmospheric chemistry for the entire living biosphere.
The implications are truly planetary. They cross every single boundary we have ever conceived of. political borders, economic classes, generational timelines, and the biological divide between humans and the rest of the natural world. So what does this all mean?
It's a lot to process.
We started this deep dive talking about a couple of guys in a desert with a weather balloon acting like they could just unilaterally fix the sky. And I think it is abundantly clear after looking at these sources that the illusion of a simple, clean, technological fix is completely broken.
Shattered, really.
We are hurtling toward a mid-century future where our tragic failure to reduce emissions might force us into an impossible corner. The painkillers we are inventing, from seizing hundreds of millions of hectares of land to build continent-sized carbon vacuums, to flying fleets of jets to spray sulfur into the stratosphere, they carry side effects that could fundamentally reshape global society, trigger climate clashes, and institutionalize energy colonialism.
And why should you care about any of this?
Exactly. Why should you spend time understanding the physics of marine cloud brightening or the economic terror of the SSP4 scenario? Because the sky above you, the oceans that regulate the weather outside your window, and the geopolitical stability of the world you live in are currently resting on a razor's edge.
We are caught right in the middle.
Caught between the urgent grinding need for rapid decarbonization and the seductive, incredibly dangerous allure of unprecedented planetary hacking. You need to be aware of the AGU frameworks, these IPCC models, and these diplomatic brawls at the UN, because the informed public's voice, your vote, your attention, is the only actual counterweight to the unilateral free drivers who might decide tomorrow that they alone have the right to take control of the Earth's thermostat.
I want to leave you with one final deeply provocative thought to ponder as you go about your day. We've spent a lot of time talking about rogue actors, the failure of international law, and the lack of consent. But I want you to imagine it is 10 or 15 years from now. The UN is still paralyzed. Emissions haven't dropped. A rogue nation in the global south facing imminent lethal heat waves. Or perhaps a rogue tech billionaire with a messiah complex looks at the inaction and decides to act. They successfully deploy a massive continuous fleet of solar geoengineering aircraft unilaterally. They break every single international treaty. They completely violate the AGU's ethical principles of transparency and governance. They secure absolutely zero public or indigenous consent. They act as total geopolitical dictators.
Right.
But the physics works. It works perfectly. It objectively and rapidly lowers global temperatures. It stops the Arctic permafrost from crossing the tipping point, and it demonstrably saves tens of millions of human lives in the developing world from lethal, wet bulb extreme heat. How will history and how will international law judge them?
That is the ultimate terrifying question.
When the dust settles and the planet cools, will they be prosecuted and remembered as the ultimate eco-terrorists who arrogantly hijacked the planet's atmosphere? Or will history rewrite the rules and remember them as the saviors of the world who finally had the courage to do what paralyzed bureaucratic governments couldn't?
We have to answer that before those planes ever leave the runway. Thank you for joining us as we unpacked this massive stack of sources today. We hope this deep dive into the source material gave you some profound clarity on the science, or at the very least armed you with much better questions for the future. Keep looking up, stay informed, and we will catch you on the next deep dive.